Okay, right then, this is a tutorial on how to wire an anti-recycle timer for a compressor contactor. To simulate the LP switch and other control circuits that bring on the compressor contactor, I've got this contactor and I'm going to press it. Right. This connector block here would be the control fuse. And out of it, I've got the start of the control circuit, which is this. That's going out to the controls, which is the LP switch, which is going to be this contactor. We also need another feed to this Schneider timer. It has to go to A1. This timer needs to be permanently fed on A1. So we're going to go out of the LP switch, or the contactor in this case, this relay in this case. We're going to come round and we're going to come into the, after we've gone through the whole control circuit, the last device in the control circuit is going to be this overload. So we come in on the normally closed switch, we come across, we've got this wire here is going up, and that's going into 15 on the timer, so that's the incomer. We're going to come out on 16. This is a normally closed contact inside here. Number 18 is not, has no electricity on it when this is dead. So we're going to come out of 16, we'll come on to A1. That's going to, so if this contactor, or rather the LP switch, is made, the contactor will energise. Right. Off of the last part of the control circuit, which is this overload here, the outgoing side of the overload, we're going to take a live feed up to the start of this normally open contact on the front of the compressor contactor, this auxiliary. We're going to come out, we're going to put a link across to A1, so that is a holding latch, right? But also, out of that same terminal, we're going to take over a signal to the timer to say that our compressor contactor has pulled in, right? So we've got that over, right? So every time this compressor closes, it tells the timer that we've started, right? Now, so normally you'd fit a delay on timer for something like this, but it's not effective in all cases if there's a problem, right? So to demonstrate, yeah, what we're going to do is going to make the LP switch, or this relay I'm using, and we're going to bring on the compressor. Now, bang. Now, if I try to de-energise the contactor because the control circuit or a bad connection in the control circuit has happened, right? But if I re-energise, it doesn't energise, look. You go, well, that's the same as a delay on timer. Now it's energised because there was a countdown of the timer, right? So I do this now. So what this will stop is, if I'm doing this, you'll only do it once when the timer's elapsed. Bang, you did it then. And I can do this all day. So this is a 3 minute timer. You do this every 3 minutes for once. The compressor would just come on one time and off again, right? You can say, well, Steve, a delay on timer will do that. Yeah. If you put the delay on timer right before A1, you think, yeah, that's great. But what happens if you've got a bad neutral? Right? This bad neutral here, nothing can happen. Right? But so what I'm going to do here, I'm going to put the camera here, and then I'm going to press it in, that there. So that's the LP switch made, everything's ready to go, but we've got we've got a loose neutral somewhere at A2 or further on down the circuit. Right? See, exactly the same happens with an anti-recycle timer. On the neutral side, see, every time the timer has elapsed, then I'm allowed one start. Then when I break it, Right? Now, if this was a delay on timer, every time I lost my neutral, this would be banging in, bang, 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 because the live is the only thing that's been disrupted, right? So, put that back in there. Now with the Schneider timer, so this contactor is latched in when that's made. It's latched, right? The actual the timer, right, as soon as this contactor is energized, this signal to Y1 on the timer at the back here, that tells this switch inside here, which was normally closed, so there was power going through 15 and through to 16 on the bottom to energize A1. As soon as the contactor is energized, Y1, because of the feed going from here to there, and then as soon as the contactor pulls in, that feed is made, the contactor latches on because we've got this bypass feed going over, tells Y1 at the top there. Let's get a bit closer. That Y1 is energized. That tells the timer, right, to swing the switch inside the timer over from, instead of being 15 to 16 that's energized as it is when it normally starts up, it clicks across to 18. So if you were to put a tester on 18, it would become live at the point at which the contactor pushes in. So if I push this, if I energize the contactor, bang, that pushes in. Y1 became live via that link there. The timer swung the feed across to 18, and the feed out of 16 wasn't there anymore, but it didn't matter because we've got this latch going across the 13 and 14 on that terminal. It goes across and it's holding on. It's put a feed to A1. Yeah, that's pretty much it. The timer is a Schneider multifunction timer, and it's the RE17 RMMU, and you have to set it on C for it to do this form of control. And then so I had it on. These are always confusing, aren't they? That's on 7, and it's set on up to 10 seconds. So that's the 10 second. That's the 10 second mark, and it's ones. So that was 7 seconds I had it on. So I'd stick it up to 6 to 60 seconds. So you'd put that on 6 to 60. If you wanted 1 minute, you'd put it on 10 times 6, is it? That'll get you 1 minute, or you click it round to 1 to 10 minutes and put it on 1, I suppose. Let's see, you can work that one out. And there we go. Right then.